Everyone. In this video, we're going to learn about different ways of combining functions. The first section will be algebraic combinations. So, meaning things like add, subtract, multiply, and divide. And then the second component would be something called composition. So, let's go through the first one. The first one is fairly straightforward. Basically, it says that the sum of functions, the functional sum is the sum of functions, and subtraction is a subtraction. Product is product, and division is division, so long as the denominator is not 0. Okay, and g of x is not equal to 0. That's the rule. Okay, now what is important here is that the domain, right, domain is going to be what is common in the domains of f and g, which means that we use the operation which is called intersection. So for example, let's say f of x is 1 over x plus 2 and g of x is square root of x. Then the sum function, that's just going to be 1 over x plus 2 plus square root of x. But the domain of this function, now you have to make sure that this is never negative and never minus 2. But that can be made sure by just having this as the domain. Right? Similarly, the subtraction of these functions is just going to be 1 over x plus 2 minus square root of x. The product of these functions are going to be 1 over x plus 2 times the square root of x. And the quotient of these functions are 1 over x plus 2 divided by square root of x, which means it's 1 over x plus 2 times 1 over square root of x. Okay. So this part is fairly straightforward. The next idea, which actually gives us a much more richer theory of functions, is called composition of functions. Okay, when we talk about composition of functions, we are going to think of them as a series of instructions. Okay, for example, maybe these could be like instructions for putting together a table, for assembling something. So usually what would happen is you start, right, put something together, or let's just call it do something, or do step 1. When you've done step 1, you end up with some output, you end up with some product. Then you do step 2, then that the product coming out of here becomes the input for step 2, so that you can apply step 2, and then the product coming out from here becomes the input for step 3, and so on. So this box diagram here for sequential action, or a series of actions, is what we are going to use to define a composition of function. Okay, so for example, I'm going to say that, let's say I take the function x squared plus 1. Excuse me. Sorry. What is that function doing? It's doing things like, if my input is 0, my output is 0 squared plus 1, which is 1. If my input is 1, the output is 1 squared plus 1, which is 2. If my input is 2, this is 2 squared plus 1, which is 5, and so on. And then let's say I am taking this and I'm plugging it to another function, which is square root of x. Now for this particular function, what are my inputs? My input is 1. And when the input is 1, the output is square root of 1. When my input is 2, the output is square root of 2. When my input is 5, the output is square root of 5, and so on. So this process is called composition of the function x squared plus 1 and the function square root of x. Okay. But one important thing to note here, first of all, is that the order matters. What does that mean? Let's say I switch the orders of these functions here. Let's say I go square root x first, and then I go into x squared plus 1, right? Let's start with the same inputs. Let's say 0, 1, 2. Square root of 0 is 0. Square root of 1 is 1. Square root of 2 is square root of 2. Now these feed into this function as input. So 0 squared plus 1 gives me 1. 1 squared plus 1 gives me 2. Root 2 squared plus 1 gives me 3. So now if you compare with the same set of input 0, 1, 2, 0, 1, 2. If I do x squared plus 1 first, followed by square root of x, then my output is square root 1, square root 2, square root 5. Whereas if I do square root x followed by x squared plus 1, then my output is 1, 2, 3. Okay, so these are different, which means it's very important to understand this, that the order in which you compose these functions matter. Which brings us to using the right notation. Okay, let's use the same example. If f of x is x squared plus 1 and g of x is square root of x, then we define f of g of x. Yeah, this is read as f of g of x. Right, so this would mean you take g of x and you replace it. So g of x is root x, so this becomes f of root x. But f is, as a rule, is defined as x squared plus 1, so this would be root x squared plus 1, giving you x plus 1. Whereas if I change the order and I say g f x, then that is read as g of f of x. Now in that case, we replace fx by x squared plus 1, and that would become, because g as a rule, what it does is it takes whatever is given to it and square roots it. This is going to be square root of x squared plus 1. And these are not the same. So they may or may not be the same. In most cases, they are not going to be the same. Okay. Let's look at an example. Say example says f of x is x squared, g of x is x minus 3. First says find f of g, which is just another way of saying f of g of x, g of f, and their domains. Okay, so let's do that. First of all, f of g of x would mean f of x minus 3, which is x minus 3 squared, and the domain of this function is everything, because it's just, if you connect it with the transformations, it's the parabola x squared shifted to the right by 3. And g of f of x is going to be g of x squared is going to be x squared minus 3, which also again has domain all of R, and as transformations this is moving down by 3. Then the second part says evaluate some values like f of g of 5 and g of f of 7. So the evaluation would be f of g of 5. What is g of 5? G of 5 is 5 minus 3, that is 2. And what is f of 2? 2 squared, which is 4. Similarly, g of f of 7, f of 7 is 7 squared, which is 49. And then g of 49 is 49 minus 3, which is 46. You could also have gotten this answer by using these expressions here, right? Or, so 5 minus 3 squared is 2 squared is 4. And 49, or 7 squared minus 3 is 49 minus 3 is 46. Okay, so that's a brief introduction to composition of functions. Next video, we're going to look at some more complicated examples and some applications. Thank you.